Hello there kitties, I'm Keri, the vacuum tube witch. And today I've got a new device in my lab. This is the ZOPAN PFL-22 Frequency Counter. And it's pretty special because it has a Nixie tube display, and you know how I like Nixie tubes, right? Or any vintage display technology. Yeah, I picked the... So it is pretty dirty and dusty, right? You may not... Now you can see... This is pretty much how I got it. And I already tested it. There are some problems with it. Let's turn this thing on. So, what is a frequency counter and how you use it, you might ask. This one is pretty simple. It has an input amplifier with some logic gates and post-signal forming circuitry. And it has a counter that counts those poles. It has a gate that lets the pulses in on the counter in a specified time. And it has an internal frequency standard. Of course, you can select the range of frequency or time. It can measure frequency. It can measure it can measure time between two triggering pulses or edges. It can measure the period of the signal. It can measure the ratio of frequencies between the A and B input. And we can also change the measurement time to suit the frequency of the input signal. But first of all, the frequency range, we can change it in a pretty wide range from 1 Hertz to like not 1 Hertz, but yeah, we can go up to something like 100 megahertz with this counter. And let's connect the generator to test the thing. Like I got the sine wave generator that I currently set to 1 kilohertz, and my previous frequency counter shows a pretty accurate reading on that. So we can rely on this 1000 Hertz. It doesn't hurt, but yeah. So if I connect the signal to the A input, I should be getting 1000 Hertz, right? So can set it to get a reading as precise as I can get. The slowest range would be the best for it. But the reading here is something like 1.18 kilohertz. That's way out of spec. So I will have to look into this device and see why it measures so far off. And now that I'm talking about the readings, I can test the reading of the internal standard generator in this frequency counter. I can press the test button and it should tell me how much exactly I have not too much happening here. Now this is counting. It goes up to 100 and then restarts, and I can disable the automatic restart by turning this knob, the reading time, all the way left to the infinity. It will open the gate just once, and when it's done it will hold it so that I can see the measurement until I press the reset button. And then it starts counting again, so I can test it on the other ranges. Not exactly sure why it doesn't really count up on the lowest. Second lowest, it counts up and it will go to 10, I think. Yeah. So this goes to 1, this goes to 10, so by extrapolation, the third one should go to 100, right? Spot on! Yeah. So the third one should go to 1000. Spot on! Thing of beauty. This shows that the internal standard generator is working properly. But I have some problems somewhere else in the circuit. Like with the amplifier and pulse forming module. Perfect. Yeah, those Nixies, they count so fast that you can't even discern between the numbers anymore. Moving one up, it will be even faster. And as soon as the counting is done, the gate indicator goes off. When I reset the counter, the gate will open and you'll see the indication here. And what happens after it goes to... Yeah. I guess that I should have an indication for overflow, but it doesn't seem to work. I'll have to look into that. Anyway, on the amplifier, we've got several controls. This is for choosing the signal level with times 1 or divided by 10. This is the coupling, AC or DC, pretty much like you have on oscilloscopes. Trigger level, also a thing that you know from oscilloscopes. Rising or falling edge. The red button couples the A and B inputs together, and the controls for the B input are the same, but in fact both inputs they have slightly different functions. The B input is for pulse type signals, while I can take any periodic signal, like sine wave, like triangle, like sawtooth, rectangular, whatever you have. And on the back side we've got several parts. The printer connector uses a DC37 DC miniature connector, and it has 8 quads of BCD outputs from the counters. So it can drive an external display, like if you have a display, a 7-segment display plus 7447 driver chip, you can drive it off from the printer connector. There are also some lines for controlling the counter on this connector. Then the switches here, they allow external or internal gate driving. You have to be careful because if you press this switch, the counter won't normally work until you supply the external driving signal. It can come in handy in some more elaborate lab setups. The standard frequency generator has the raw output of 10 MHz, and it has a divided output depending on the range that you choose on the front panel. The generator can also be driven from an external standard generator. And then the counter, not the generator. Yeah. And this switch chooses between the built-in and external standard generator, we've got fuses, and we've got a memory setting that affects the reset circuitry. This and also two of those hidden underneath this cover are old school TO3 voltage regulators. Like, you know, the 7805, 7812 and so on, that are typically in the TO220 package. Old school voltage regulators often used TO3, like the 2N3055 transistor. And yeah, those large metal packages, they are quite good for dissipating the heat. So let's get into this thing. It's a little bit complicated. And to open the enclosure, I need to start removing the plastic inserts on the sides. Careful not to drop those teeny tiny screws. I can remove the side panels, but I don't have to do this. What I have to do is removing this bar. Attached with 3 screws. That's the 1970s style ZOPAN enclosure. Later on they slightly modified the design and got rid of those T-bars. Yeah, this was made in 1982. So, what happens after I slide off the top cover? So, first of all, we can see a piece of sheet metal. This is in fact the Nixie tube cover. It prevents any light from getting from the back. I can remove it now. And of course this board, this is the counter board. Uses 7490 counter chips. 7475 latches and 74141 Nixie drivers. 8 of those because we've got 8 Nixie tubes here. So when I take this one off, it has some foam inserts, but the foam doesn't want to foam anymore. It turned pretty solid over the age, but I will leave it in place. It doesn't fall apart. We've got Z573M Nixies made by Eastern German vacuum tube factory WF, Werkfernseh Electronic, I think. And the display and counterboard, if it lifts up, it has a pivot on the back and lifts up pretty easily now that the Nixie tube cover is removed. Yeah, let's change the view. And underneath the counter and display board, we've got the frequency dividers and the range switch. The function switch here, the measurement unit indicator. Those indicators, if I'm correct, they use incandescent bulbs. Let's try to take the board off. Look at those little lovelies. Look at that! Thing of beauty! Joy forever! I really have to be careful not to tear any one of those light bulbs off. If they were damaged, I could consider changing them to LEDs, but I'd rather keep it traditional. There are markings on the board and there's also one resistor. How cute they are. 33 ohms. 33 ohms resistor powered from 12.7 volts, and it goes to the common line for the light bulbs. And I guess that they are collector driven from some transistor circuitry. Yeah, let's put this back together. Maybe I'll do it later, but yeah. Now it's time to take a closer look at the counter and its internals. So we've got the counter board and we've got the power supply board. It has 3 full bridge rectifiers built from individual diodes. It's all very dirty. Definitely not a thing of beauty here. So I guess I will have to clean and recap this thing. Because those blue Elva capacitors, they are considered very unreliable. Maybe not the most unreliable capacitors made in Poland, but pretty close. So we've got the switches and connectors on the back panel. And oh my goodness, I guess that getting the board out of the generator, out of the frequency counter I mean, I think this is gonna be a lot of work. But I can't really see a different way of tackling the problem than to clean it in an ultrasonic cleaner and then wash it with isopropyl alcohol. But there are also a few interesting features of this frequency counter. Look at this. You know what it is? This is a oven controlled crystal oscillator. Hewlett-Packard used those in their meters, of course not the same model, but ZOPAN uses a OCXO, pretty much like Hewlett-Packard did in their legendary gear. I can unscrew the 3 screws and try to take it out, just to show you how it looks like and maybe how it's built inside. Though this is gonna be one hell of a journey. It's dirty from the upper side, but quartz generator GWM 5-1. It's 5 megahertz and the master standard frequency of 10 megahertz is taken from it through a frequency doubler. On the upper side we've got a plug that covers a adjustment potentiometer. Like we got a hole, and through that hole a potentiometer should be accessible to set the frequency. Yeah, I wonder if I can get the cover off. Two of the screws are off. Third screw off. So, ready to reveal the mystery? Wow, look at that, we've got green felt. Beauty! This is, this felt, it's the thermal insulation. And here we've got the hole for adjusting the frequency. The standard generator has two printed circuit boards. This one controls the heater. This one is the generator itself. It's pretty full of solder. Just a teeny tiny bit too much solder for my taste. It's a single layer board. Both of them are a single layer. And in the center we've got the proper thermostat unit with a heater winding around the whole thing. We got a transistor that's coupled with the thermostat block. It's a temperature sensor and a auxiliary temperature sensor because the main one is a negative temperature coefficient resistor, aka a thermistor. And yeah, it looks like the thermistor is placed right underneath the heater winding. Or are those wires just for the heater winding? I'm not so sure. The latter might be the case. Anyway, if I try to discombobulate the thermostat block some further, we'll see some real thing of beauty. I don't think that my drill down will throw off the adjustment. Hope it's not the case. And now I realize that I might have been wrong about one thing. The real thing of beauty comes right up, and you can see it now. This is a quartz oscillator in a glass tube. Looks totally tubular, right? Look at that. Also a piece of felt. And it has handwritten markings on the side. I would have to desolder the protective cage or screen to view it in its full glory, but yeah. Yeah, there are some parameters written on it and quality control seal. And this coil, as a matter of fact, the adjustment element for setting the standard frequency, it's not the potentiometer like I said before. It's a coil, a ferrite slug, I think, or metal slug. Metal slug! That can be driven further or closer, changing the inductance of the coil. And this coil also stabilizes the output frequency against the aging of the crystal. A really well-designed device. There's also the felt on the other side of the crystal tube. And it's made out of a block of solid aluminum, keeping the temperature stable. So it goes back there, and I will put it back together. This thing of beauty. Thing of beauty made in Poland, because not all the great stuff was made in USA. Mind me. Yeah, I wish I had a Hewlett-Packard 5345, I guess, frequency counter like those used in the Apollo program, like those featured by Curious Mark, but having a ZOPAN unit with Nixie tubes and a oven-controlled crystal oscillator, it also is pretty splendid. there's also some even older test gear made in Poland by Elpo. The digital voltmeters and frequency counters, very early digital tech stuff, and I recently learned about those devices. And guess what? They have all kinds of very uncommon display technology, uncommon in my country. Like projection displays and edge-lit displays. The stuff Fran loves so much. And looking at those display technologies, you realize that Nixies and VFDs, they are really not all that lovely, because Nixies and VFDs, they are pretty common. And if you look at some really old stuff like edge-lit or projection displays, then you have a completely different point of view regarding what is commonplace and what is a rarity. Nixies, they are not really all that rare. And VFDs, nowadays VFDs are pretty common, and you find them in all kinds of 1990s gear. But the really rare and uncommon stuff, those are those older displays that didn't make it to the equipment through for a long time. They were pretty short-lived technologies. So now I'm putting the crystal oven back together, hoping that it's gonna work. One more screw. One more screw, no more screw-ups. So I broke the seal on this OCXO to show you how it looks like on the inside. And I also broke the signal connection. I have to repair this. And there's one more thing I'd like to show you with this frequency counter. If only just one. On this side, let's lower the camera. This is the gate indicator, and this is probably the single LED that made it to this device. Back when it was produced, LEDs were not that common and they were pretty expensive. The industry still used incandescent bulbs for most of the applications. Today it's a no-brainer that we use LEDs. But this block, it has, not sure if I can drag that out, but it has two neon indicators. One in this hole and the other one in that hole. And those neon indicators are for the range overflow indication. I think they might be driven from an open collector, but I'm not so sure. So if I place the negative lead on the ground and measure the voltage, 217, the Nixie tube DC supply, pretty spicy. Be careful, as this thing is pretty spicy, and this would be the bottom side of the neon indicators. If I connect the meter, I can see it glow. Maybe if I turn the counter around. Maybe I can get it to show the indication. So I have to measure the voltage, that's all it takes, right? I can see a very faint light. What if I try just shorting it to the ground? Now it's pretty visible. Over range. So we've got three kinds of indicators next to the Nixies. We've got neon lamps, we've got LED, and we've got incandescent bulbs. Quite a wild collection, right? And the input amplifier, it can be pulled out of the device. In order to do that, I have to release a screw on the bottom part. Now I can pull the module out, just like that. It uses double-sided PCBs, but on the top side it's very dirty, and I think that this might be the cause of incorrect frequency indication. Like the grime, the dust, it introduces parasitic resistance and capacitance. And this might affect the measurement. And I'm talking about the A channel in particular, because this one is used for measuring the frequency. But all the module, it's very dirty. I think that the frequency counter was kept in some storage with with a lot of dust and maybe oil, like in old factories. If you had an oily environment, the oil will depose on almost any surfaces. Can say it about cigarette smoke as well. So it's another reason why you just don't take up smoking, right? Gotta promise it. So my further plan for the frequency counter is desoldering all the connections from the boards, taking it apart, cleaning the front panel, cleaning the front panel, the rest of the enclosure, cleaning the boards in an ultrasonic cleaner, and then recapping and recombobulating the device. Now I'll just take a look at the test, just to see if I didn't mess anything up. The internal standard test. So on this range it should go to 10,000. Yeah, that's right. Maybe I'll get the overrange indication again, but I didn't. So I think that I will have to look into that to determine what controls the overrange indicator and when it should go off. So it looks like my discombobulation or recombobulation of the oven-controlled crystal oscillator didn't throw the adjustment off. That's good. And yeah, I will have to put quite some work into restoring this generator, and after I'm done, I'll just added to my test gear collection here, above the PO25 sine wave generator. My third ZOPAN device, and I like it a lot. Yeah, looks like the indications are right. I can also take off the bottom cover to show you the printed circuit board. And the procedure is pretty much like for the top cover. You just unscrew 3 screws that attach the bar. And it slides off. Looks a lot better from the bottom side. There are traces of rework on the full bridge rectifiers. Also some traces of heat. The board is slightly brownish in the rectifier area. And of course the board is double-sided. It has plated vias. Those were pretty uncommon back in the day in Polish electronics, but some works did order those. Generally there was a single PCB manufacturing house named Toral in Toruń, and they made PCBs for all the Unitra industry, but also for the professional electronics manufacturers. And they made all kinds of PCBs. They made glass epoxy boards like this, like FR4, though I'm not so sure if this is actual FR4. They made phenolic substrates, and those were mainly used in the everyday use non-professional electronics, like hi-fi gear, TVs, all that kind of stuff. And double-sided boards were pretty uncommon, and if you saw one, it was certainly on the glass epoxy substrate. I didn't really find any double-sided boards on a phenolic substrate. And pretty much like Toral was the to-go manufacturer of printed circuit boards for the Polish electronic industry, Zatra in Skierniewice was a manufacturer of transformers. So this one will also certainly come from Zatra. They made standard models, and they also made some custom specifications for different factories, if they ordered larger quantities, they could have had transformers made to a particular spec. So, let's get back. That would be my new toy. Big girls like new toys. And I like electronic toys. To each their own. So I think that I will do a lot of work on this frequency counter off camera. I won't document everything because this would be a pretty hard thing to do, putting a lot of time in the project. But I might make another video about it after I'm done. After I clean and recombobulate this thing. This is gonna be one hell of an Atkelar style project. Taking it apart, restoring, putting it back together. A challenge, but I like technical challenges.